So we are here to talk about the Internet of Things in the business. We have three distinguished gentlemen doing very interesting things in this space. So first we'll just introduce them a little bit, let them give them a second to talk about their companies or what they're doing in this space. And then we'll ask a couple of questions that we have to seed a good conversation around Internet of Things for business. So first we have Alok Batra, and he is the CEO of MQIdentity. He has, over his years, several technical roles in large companies such as GE or Cisco, but also in small startups. So maybe you could tell us a little bit about MQIdentity.
Sure. We are focusing on M2M2B. So like how do you connect the machines into the business environment, and how do you bring the business awareness in the machines? And that's where we are focusing at MQIdentity.
Great. And next we have Dr. Amine Haoui. He is the CEO and co-founder of Sensys Networks, has quite a bit experience in wireless communications. So maybe you could tell us a little bit about Sensys Networks.
Sure, a pleasure to be here. So Sensys Networks, we are a wireless sense networking company focusing on the transportation vertical. We supply a complete solution of sensors that go in the pavement, access point that collect the data, and cloud-based or server-based software that manages the data and does the analytics in support of traffic management, travel information, traffic information systems, and a lot of safety and parking applications as well.
Right. And then last but not least is Banny Banerjee. He teaches design and innovation strategy at Stanford and also is the director of the ChangeLabs at Stanford.
Thanks for having me here. So I teach innovation methodology at Stanford, and I head ChangeLabs, which is essentially a think tank / action tank, highly networked organization with links to many other educational as well as non-educational institutions. And what we are trying to do is to come up with innovation methodologies that are not just targeted at services and products, but develop ways in which to address very large-scale challenges, particularly the grand challenges that are facing humanity today.
Great. And so in the past sessions leading up to this, we talked a lot about the Internet of Things and what's going on the residential side. There's quite a revolution, or an evolution at least, around what's going on in the connected home space. And I'd like to hear kind of what we're seeing from an evolution perspective and in the industrial space. So Alok, you want to start with that?
Right. So if you look into industrial or business side, M2M is not new. Like industrial, whether you take manufacturing, you take aviation, transportation, machines are always connected. Like smaller, sometime in a smaller scope, sometime larger scope. The difference now which is happening is basically you're looking into a next level of integration when you're not looking one machine at a time. You're looking into a system of machines which are organically maybe put together. How do you support that kind of environment? And surely it starts from, I'll say from three perspectives. What's the value which OEM can bring it to their machines? So remote monitoring and diagnostics, field support services, so that they can keep looking into their machine continuously, do the predictive analytics, and provide the services before it is known to the customer. The second is more from looking from the operator's perspective. Like from operator's perspective, you're looking into how you can manage the machines as so that it can keep working in your business environment. And we are seeing that there are a lot of evolution going on that side, where people are now creating new applications so that they are not like creating one machine operation at a time, but like looking into a cluster of machines, whether it's the operating room environment, whether it is a process assembly line environment. So that's evolution which is happening on the operator's perspective. The third, which we are not seeing much, and this is where we're trying to focus on here, is from business perspective. Like how do these machines come to my business? Like today, the machines pretty much break the business flows. If you have a business flow which works perfectly fine, and suddenly your machine goes down and everything is affected. So like how do you make sure that machines become part of your business flows and machines collaborate with the business processes as people collaborate? And this is a third area which surely is starting. But if you take an OEM perspective and you see operator's perspective, there's a lot of things which is happening now as you support not only just engine, you're supporting the whole plane. Like how do you make sure that your plane can be told like what things can affect its flight schedule. At the same time, if you look into the like energy space, you're looking into the whole wind farm rather than looking into one wind machine. So like how do you make sure that efficiency is maintained at the farm level, not just at the machine level? So a lot of those things which we see, which is happening just because now we have the opportunity to connect machines with each other and create the applications at much, I'll say, cheaper cost. It's not that it was not possible, but now the cost of development has gone down drastically.
Great. So Amine, do you see some of those same changes or additional ones from your perspective?
Yeah, I mean, in the transportation space, I think is one space where IoT or if wireless sense networking with IP-based application has found a very nice space because there has always been a very big need for more data collection, more information about the performance of the roadway, the traffic signals, the parking. And it has always been very hard to collect that information and manage it and run applications on it. And where wireless sense networking or IoT has found a very nice niche that is very fast growing today is in precisely solving that problem, where cities that have operated with very limited data until now are finding a lot easier to deploy wireless sense on a very large scale and then act on the data to improve whether traffic signal control or their parking information system or the information to the drivers as to what is the best route to take. So 10 years ago, we were one of the first companies in that space. We pioneered the idea of using wireless sense networking for traffic management. Today, you have probably 20 or 30 companies that have developed products that are addressing various verticals. Parking is a very successful application for wireless sense networking and transportation. Traffic management is a big one. Safety is a very big application that is attracting a lot of attention right now in terms of averting accidents if possible, if you can detect vehicles on a collision course or what have you. So it's definitely a growing field and it is having a big transformative impact because suddenly it used to be they were data poor and operating relatively without data, and today there is a lot more data and the question becomes more of the apps that use the data need to catch up a bit now.
So in the residential space for Internet of Things, especially in the connected home, really what we find at iControl Networks is the peace of mind value proposition is really what's selling, right? That's what people really are attracted to for the connected home, and it really becomes very compelling for them to purchase. Are there equivalent killer apps, right, on the business side that we're seeing, or again, a room full of entrepreneurs? Where would they focus their attentions to really see the growth on the industrial and the business side? Do you have any opinions on that?
So when I say peace of mind on the IoT side, it's a piece of life from the industrial side. You can't see engine falling down if you don't have the right connection between engine and the control room and the OEMs, so that you know ahead of time what's going to go wrong with your machine. So it is, when you look into the industrial side, the three things which is most important, and Amine did mention one of them, like safety. The other two, which is your productivity and efficiency. And those three are basically driving this market to take to next level, where you're not looking into a smaller changes, but you're looking into now how much efficiency you can increase at the system level, how you can make the people more productive, because multiple reasons, like aging was discussed like in the last session. Aging is affecting the industrial world too. You're losing the people who learned how to run the machines for 30 years, 40 years. You don't have next generation which can come in and pick up from day one. So the expectations are different. So it's very essential for this kind of environments where you basically you bring a kind of applications which can help to have the better efficiencies, more productivity for the people, and you can make the safety, increase the safety for them.
Great.
Yeah, there are many big drivers for the Internet of Things in transportation, which is my domain. That's all I'll talk about. But it's a huge domain because the fact is that the road networks are at capacity and the demand for travel is going to continue to increase at a very fast pace, but the rate at which we can increase the road capacity by building roads is very limited. And therefore, using these networks more efficiently and optimizing the performance of the road network has become a big priority. Whenever you talk about optimization, you're talking about measuring what's going on. And there is no better way to measure it than by deploying wireless sensor, bringing it back to the cloud and doing the analytics on them. And there are very, very big examples of very successful large-scale deployments. A good one would be in Melbourne, Australia, where they have instrumented 80 kilometers of the major M1 freeway in the heart of the city, instrumented the entire main line, all the ramps. They could measure everything that's going on the freeway to implement traffic control, so they control the rate at which people enter the freeway, they control lane speeds, they detect incidents, they provide better information. They were able to reduce the commute hour from 3 to 7 by about 1 hour. And they were able to reduce the accidents by about 30%, which is very significant. So these are very big drivers for, and that's a very spectacular implementation because it is thousands of sensors. So if you talk about IoT in action, it's a very, very good example of that. And there are many other similar examples. Safety is a very, very big application. There is a growing trend in the US, for example, to be able to detect cars arriving at an intersection at a very high speed, so you don't turn the signal from green to red because you know it's going to cause an accident potentially. If you cannot measure the car arriving, you cannot do it, and that's where IoT is helping quite a bit. Parking is a very, very big driver. 30% of congestions in cities is due to people looking for parking. It's a known fact. And if you could inform them where they could go because you have sensors in the spaces and you have the analytics and the apps on your phone that will inform people where they could park, that's another big...
a lot of issues with that in San Francisco.
Absolutely, yeah, no kidding, yeah. And there is an even bigger wave coming that will require a lot more of the same, which is the fact that we're going to start paying for our roads. And already HOV lanes in the Bay Area have become hot lanes, HOT, so you can pay toll to drive on them. And the rate is based on the congestion level. So how do you measure that? That's, again, IoT application, being able to measure congestion on all these lanes of freeways. So you can set the rate at the appropriate level to control congestion. So there are many. We're in a very rich field, for people looking to start companies. The number of applications are immense, and they're starting to take off because there has been acceptance of this technology as being part of what traffic engineers do. And so it's a growing opportunity, very big market opportunity that's opening up right now.
Great. So Banny, you're more on the user side of IoT. So what kind of trends or behavioral changes do we see on the user side that's really influencing the business growth for IoT?
I think that because I work in the innovation space, I'd rather speak about what I think is going to happen rather than what's happening right now. But there are early warning signs, and both the other panelists mentioned this as well. But in my mind, there is no doubt that what we're looking at is a scenario where upwards of 50 million devices suddenly get connected and are on the cloud one way or the other. And particularly combined with all of the other kind of technologies that are simultaneously taking place, I think it's fair to say that might spark a completely different era of computing. And I think one of the really interesting crossroads and a possibility is the fact that you're not just modifying infrastructure systems and technology back end systems, but you're actually modifying human behavior. So if you have, for example, what Amine just said is that you have a connected road and there's a different pricing system, etc. Ultimately, what you're doing is you're changing the way humans operate and how the city operates. And this is the signal that I see a lot, because apart from working with think tanks, I also work with governments and big companies such as utility companies. And if you look at the kind of position that a utility company might be, now take a utility company such as E.ON, which is by no means in a unique position, but E.ON is a very large utility company in Europe. It's seeing changes in laws due to carbon emissions and climate change related laws that are going to levy all sorts of restrictions on what you can do and the total amount of emissions you can have. And so it realizes that if you still have to serve people the same amount of energy, one of the ways in which you can still be in business is if you somehow change the entire demand architecture of how much energy people are consuming. And so what is incumbent on them is to find ways in which an entire nation or a set of nations change their behavior at the residential energy level such that they show a marked difference in how much energy they consume. Now that's a really hard thing to pull off, and what we're finding is that if you take a continuum where here is the technology and the way the built architectures worked and the way the inside of a house works or the way the roadway works, etc. But you instrument it and you create this very, very smart pieces of data, or rather very large sets of data that can be mined in smart ways. And if you create feedback systems with the right kind of transaction and incentive systems in place, then essentially what you have are the makings of behavior change. And that is something which is of tremendous interest to governments and to cities and to utility companies, etc. So we will see more and more things that are not just clever little things that go into a house with blinky lights, but really profound ways in which we interact with our built environments and our infrastructure in new ways.
And so we talked about it a little bit with this analytics and the big data analytics. So a lot of that analytics can be applied to, understanding what people are going to do and applying those analytics to predict the best technologies and the best types of solutions for certain scenarios.
Can I add on that? I think one of the genuine promises for the Internet of Things technology is that we've happened upon an era where computation, at least for the developed world, is the penetration has been very high, and all of us have multiple devices that are capable of computation. And while we are enjoying a certain privilege of being tremendously connected and augmented in our abilities, technology cuts both ways. And there are many, many societal issues that have been caused because of technology. So we have choice overload, we have decision overload, information overload. We are impoverished in the currency of time. We are spread very thin in terms of our attention. And the next era of computing had better give us back some of that what we've lost, rather than creating an exponentially noisy world where we have to deal with a whole lot more decision making. I really don't want my faucet asking me whether I want to use this temperature because a certain number of trees are going to get cut down, etc., even though I work in the sustainability space. What is a far more interesting thing is, given the data and the data sets, and given the emerging ways in which one can mine the data and feed the data back in interesting ways, are ways in which one can create expert systems and predictive systems, where given higher order directives, one can figure out the heuristics by which the system should behave, and pretty much take control over what it does, such that it creates a much, much more seamless experience. So I would say that at the experiential level, creating genuinely need-driven, seamless experiences such that life is simplified is a huge opportunity for business.
Absolutely. So one of the challenges, and again, we've kind of talked about it or themed on it in a couple of the sessions today, but is the Internet of Thing versus the Internet of Things, right, and tying it all together. And so one of the challenges that we have, right, is how do we tie it all together in the residential side. That's really a big challenge that we all have to overcome, kind of, again, to your point around analytics. What kind of challenges do we see in the business side of IoT?
So if I talk from industrial perspective, traditionally the world has been very slow changing world. Like it takes far long to develop the technology, takes a lot of time to put the system together, and then you expect that system to work for many years before you make the changes. And that's surely a hurdle when you bring something which is fundamentally different approach, where you point to what Banny said, where you don't want to make people work with the technology. Technology should become invisible. What they should work with the apps, with applications, like very much similar to iPhone. You don't see the sensors, you don't see the like how the phone works. You work with the apps which hide all the technologies behind the scene. It's doing computation like basically pretty much continuously and giving you a seamless experience. And the same thing which we want to see in the industrial world, where people can become more app-centric rather than machine-centric. And to take that change, it's going to take time. It's not going to happen overnight. There are industries which have higher level of demand to make the changes, so they will move faster. Like industries like I was mentioning about, where you have more field force requirements. You cannot afford to have sending people at every place and measure like what the level of tank, which is like current or the, let's say even 5 years back state. You have to figure out how do you put sensors so all that information comes to you rather than you sending a person. And those kind of industries will make a much faster approach. Other industries may take a little slower, but the world is going to change, because once you put the expectation in front of people how they work, then pretty much industries have to move. They have no choice. And this is where the point what Banny raised. It's basically you have to drive from both sides, from the industry side and from the consumer side. And this whole consumerization is basically going to affect the industrial world.
Yeah, I see some of the same challenges actually that you may be alluding to, which is the fact if you take, again, back to transportation, if you take an effective solution for a city, you would have to integrate data from vehicle, buses, trains, bicycle, pedestrian, parking information. And today, these are all silos. Different companies are attacking different problems, different technologies, and there is no standard or there is no sort of unifying methodology of providing data. It's starting to happen, but I think it's pretty challenging because of the complexity of what we're looking at and the fact that there are no, if you want, commercial motives to push this forward. This is, there is, in government there is no profit, so there is, it's a bit of a harder thing to monetize and to fund, if you will, and make happen. But certainly there is a big need for looking at the bigger picture of all these silos of technologies and how we can integrate them better. And that's possibly where analytics come into play, because if you agree on certain interfaces and certain basic data formats, then it can be solved at a higher level potentially. But we see it as a hurdle today, and the wider application of what we are doing is the fact that it's a heterogeneous environment and different data silos are being addressed by different companies.
I couldn't agree with this more, because what a certain kind of standardization, or at least a certain level of interoperability between systems buys you so much at a larger scale. Amin's company is in the business of creating an entire infrastructural system that allows a very, very different kind of optimization at the level of transportation. And if one were to take a step back and raise it at one level of abstraction, what I think is happening is that it's one way in which to attack the tragedy of the commons. The tragedy of the commons is that I just want to get into the car and get on the road, and I just want to get to my meeting by 8 o'clock, but so do the other 200,000 people on the road, and collectively we create an emergent behavior, which is a traffic jam, right? Now, if you look at what is an emergent behavior and the tragedy of the commons, all are grand challenges. The energy crisis, the food crisis, the water crisis, etc., you go down the list, are all tragedies of the commons playing out at grand scales. And there is no one entity that is enabled or incentivized to deal with it, which is essentially the manifestation of the problem. But if you, at a theoretical level, if you have these platforms, and so for example, everybody agrees that if all of us use a little bit less water, a little bit less energy, we are after all in the midst of a drought, it would be great. And all the incentive packages that the utility give us and so on have a really miserable uptake rate, right? They don't work particularly well. And yet we know from the behavioral scientists that actually behavior can be modified, and there are very, very robust ways in which behavior can be modified profoundly. And what I'm really interested in is if you create these larger platforms, you have an ability to incentivize the right kind of behavior. So if I have a way where it's not just telling Caltrains where the traffic hotspots are, but it's basically telling me when I still have the time to decide that this might be a good day to take my first meeting on Skype and start off later, or better still, there's somebody who's from the neighboring street who's also headed to Stanford. That creates the makings of a very different kind of a community, including the possibility of shared systems, etc.
Great. Well, I think we are out of time, so I'd like to thank these gentlemen for offering their expertise on the Internet of Things business.
Thank you very much.